Okay, so I'm gonna get started. If you still have the quiz to do, just wait for the end, and you can like fill it out at the very end. Okay. So just a quick reminder. Like discussion is mandatory. So if you miss more than 2 of your discussion sections, it starts impacting like your decal grade, and we don't want to do anything like bad. We're like not trying to be, I guess, too mean about it. We'll let you miss at least, I mean, at most 2, but then after 2 it starts counting against you, okay? So today is a very exciting lecture. We're basically going to go over, we're going to take everything that we've learned from Bitcoin and all the distributed network aspects and the cool technologies that we've learned and take the next step and apply it to the world. So we're going to talk about decentralizing the future with Ethereum and smart contracts, and then Gillian is going to take over from there and start talking about when to use like decentralized applications and different use cases. And we really just want you to learn to ask the right questions and make more informed decisions in the space, like when to use a blockchain or when not to, right? So that's what today's lecture is going to be. We'll start off with smart contracts. We'll get into Ethereum. We'll talk about a little bit about the Ethereum virtual machine. And then Gillian's going to do use cases and the state of the ecosystem. Okay? So smart contracts, right? So first I want to pose this question to all of you guys before we really start. What makes Bitcoin so special? Like, what is the underlying technology we're so excited about? Like, what do we talk about when we're talking about Bitcoin? Like, if you can take like 5 to 10 seconds to like just say something to your like neighbor or something like that, and we'll reconvene. Or does anybody have an answer like right off the bat? Does somebody want to shout out an answer? Yeah.
It's the first one, the Big Daddy.
Huh? Okay. I guess we're looking for like along the lines of like Bitcoin or I mean blockchain or something like that. But okay, sure. Does anybody have another answer or? Yeah.
It's a new money, so it's blockchain that's only for money and currency.
Okay, I can see that. So personally, how I would answer this question is the idea of a distributed network. So if you're totally lost for the first 4 weeks, or if you're just finding this lecture online without really any context, what I really want you to get out of this or remember is the idea of a distributed network. So Bitcoin isn't the first to like pioneer the idea of a distributed network, but it was one of the first to combine these 3 main ideas into its own network, right? So the first idea is cryptographic identities. So stuff like public and private key cryptography that really allow you to reveal nothing or no information about yourself whatsoever, but still be able to 1, authenticate and sign off transactions, 2, prove and claim ownership of some digital asset, and 3, attribute accountability or blame to somebody for their past actions, even though you don't know who they are, and even though the system is supposed to be anonymous or pseudonymous, right? So that's the first aspect. The second is the idea of a consensus protocol, right? More specifically, Nakamoto consensus, and what I mean by that is tying down your voting power to a specific external resource, like computing power or some digital asset. So even though we don't know the people in this network, or there might be people with multiple identities or people with more power in the, I guess, regular world, we can still come to a democratic decision using some kind of consensus protocol, right? Like proof of work or proof of stake or some other alternate consensus mechanism. And the third thing that I want to talk about is the blockchain, right? So this idea of having this immutable source of truth, it's like this ledger that we can add to but not edit afterwards, right? This is really important when we're talking about the idea of this data structure, because this helps keep things secure and in this distributed network, right? So clearly we have a lot of benefits when we use a distributed network, right? If you remember to the buzzword slide that Nadir shared the very first lecture, you get this idea of trustlessness, right? I don't need to know who you are, you don't need to know who I am, but I can still come to some sort of agreement, and everyone in this network can come to some sort of agreement, right? and using this consensus protocol, right? So this decision, and then we have this idea of trust in the consensus protocol, that this decision that we come upon or make as a group is in the best interest of all of us, right? We also have this idea of an immutable ledger of truth. So once we make a decision, it can't be unmade, right? Once something happens, it's like set in stone and it can't be changed. There's no central point of failure, and there's no one way that one person can gain control of the entire network, right? And this is really exciting, right? So a lot of people might ask, why don't you just do everything on the blockchain, right? Why don't you just try making decisions using some sort of consensus mechanism, right? And the short answer to that is it's not really meant for everything. You have to do a little bit of your thinking and I guess make your decisions for yourself, right? But we'll teach you how to make those decisions in this lecture. And the most basic form that use case that we come across is the idea of a smart contract, right? So first, let's go into what a contract is in the traditional sense, right? A contract is some sort of agreement that you come upon with another party, right? So let's say if me and Gillian want to enter a contract, we agree on something and then we write that down into, like, let's say a written contract or something like that. And the idea is that when you write down this this contract, is you have some sort of muscle behind it to enforce it, right? You can have some sort of law enforcement, or you can have a justice system that really ensures that no one tries to violate the agreement or the terms of your agreement, right? And that's the main goal of what a contract's supposed to do. But of course, our English language is a little bit flawed. It has its own ambiguities and nuances, like most human languages, and it's really open to interpretation, right? And so contracts are sometimes or occasionally violated, right? So next we come across this idea of a smart contract, right? Some people had the idea of, let's say, using or creating this smart contract idea. So Nick Szabo, he coined this term back in 1996, smart contract. He said, okay, why don't we take the terms of our agreement and write it into some sort of programmatic code, right? And this way, we have this code that's pretty deterministic. If you run a program, no matter how many times you run that, it should give you the same output, right? Unless you're doing something with random numbers, and we don't want to get too much into detail. But it's always going to give you the same output, right? The idea is we take all these agreements that we have, and we write it into code so that it does the actions that we want it to do. So rather than having to trust someone to do the actions that we state that they should do, we just let this program run and execute, right? Obviously, the caveat to this is that we need some sort of trusted entity to run this code so that we can verify that the output that we get is what we intend it to be, okay? And that's where, I guess, does anyone have any quick questions right now? Not really? Okay. Oh, wait, yeah.
Wait, so you said trusted entity must run the code, so essentially, like, you have to verify that when the entity ran the code receive the same output?
As in, when you have such a smart contract, you want to ensure that it does its thing properly, right? So you have someone that you know or someone that you trust run it so that you can, like, I guess, verify that this is a correct output or something like that.
Would that be like something that's like verified by the network itself? Or?
In this case, it's just like, in a general sense, it's someone that you trust. We'll get into like the network sense later, okay? So moving on, here comes Ethereum, right? So they call themselves a blockchain smart contract platform, which means that they enable the idea of they enable the use of smart contracts, but they take away this idea of a trusted entity needing to run your smart contract and replace it with this trustless distributed network that we get from Bitcoin, right? So this is a high-level review of what Ethereum is. You can think of Ethereum as this huge distributed computer that executes smart contracts and has this sort of network state. And what I mean by that is that it has its own universe, or you think of it as its own little universe, the Ethereum universe. And this like tiny little world, you have smart contracts and transactions happening between different people, between different contracts, and all these different transactions or changes allow it to change the data of this world or change what's happening around this universe. So this isn't very different from what Bitcoin is actually. Bitcoin's world is actually just a transaction system. It's just a list of who owns which Bitcoins, like the UTXO model that we've been talking about this whole time. And every time you send a transaction, you're basically transferring Bitcoin from one person to another, right? To another entity. In Ethereum, you're doing a little bit more complicated things. You have smart contracts that do more complex things, and changes that you make to the network are more fancy than, let's say, just transferring ownership in Bitcoin, right? And so fundamentally, Ethereum is its own like cryptocurrency. It has its own native asset, which is called Ether. And a quick show of hands, does any of you own any Ether? Okay, cool. So yeah, even though Ether is like the most, it's not the, as in, even though Ether is it's its own cryptocurrency and it's the basis of value in the Ethereum network, it's not the whole main idea of what Ethereum is centered around. What we want you to, your main takeaway is that we wanted you to remember that Ethereum is, at its core, it's a smart contract platform, okay? A lot of times we hear that Bitcoin is hailed as like this Bitcoin 2.0, right? But I really want to emphasize that there's differences between the two, even though they share like similarities as like the distributed network aspect that I stated before. One thing that when people started to notice distributed ledger technology is that they were very emphatic, and they were like, let's create these decentralized autonomous organizations, or DAOs, or let's like create a whole new nation and run it or govern it using smart contracts, right? And this is really cool, but do we build this like this idea on top of Bitcoin? It makes the most sense, right? Because Bitcoin is already an existing network. It's the most established one, and has pretty well tested security, as in it's been around for a long time and it hasn't been like hacked, right? But we have to remember that like there's several obstacles that you come across when you're dealing with Bitcoin. One, Bitcoin is very simple, and at its core, it's meant to do just one thing and one thing only. It's to send money around, right? Its scripting language, Bitcoin script, is really basic, and it doesn't have that many functionalities to implement more complex and fancy things that you want smart contracts to do, right? So lastly, the Bitcoin network or the Bitcoin community is quite conservative, and they're not really open to like major changes, especially to their protocols, right? So Vitalik Buterin, as we see here, he decided that he wanted to move on to like bigger and better things and more Turing complete kind of things on a different platform. So I want to take some time to compare the two networks, right? Like I said, Bitcoin is very simple, but that's what it was designed to be, like the most plain flavor or basic version. So it's just the transaction system at its core. It's really robust and it's really secure, but it's often regarded as the gold standard because of like these reasons, right? On the other hand, you have Ethereum, which comes in this like smart contract flavor. It offers more complex and more features. Its scripting language is Turing complete, meaning that you can do more advanced things with it. And even though it has its own asset Ether behind the scenes, its primary incentive isn't really to be like the cryptocurrency. It's mainly there to fund the computation of your smart contracts or execution of your smart contracts. And second of all, it's to align incentives. So like miners who've mined valid blocks get rewarded with a block reward. So yeah, currently they both use proof of work, but Ethereum, I think at its current stage, is undergoing like updates to transition into proof of stake by like the end of this year. Yeah, so a little bit more about the implementation details. We have Ethereum with a block creation time of around 15 seconds, while Bitcoin's is around 10 minutes. And why do we have this per se? We want this because we're dealing with smart contracts, right? That need to be executed and need to change the state of the network on the fly, right? So we needed to update quite frequently, so that's why we have like this block creation time of like 15 seconds. And obviously, because of that, we have a different like block reward. And currently, the hashing algorithm that Ethereum uses is different from SHA-256. It's called ETH-hash. It's currently ASIC resistant. That's why you see a lot of people who mine Ethereum using GPU miners. And currently, like the exchange rate is around like $800, something like that, right? And next, I want to go into a little bit more about, or quick question: does anyone have like any questions that they want clarification about? Yeah.
So this is ASIC resistance, but how do we? So ASIC is like some sort of like a chip or something that's designed to mine, like designed to work for SHA-256, right?
Not specifically SHA-256, but it's application specific. So you want to build it so that it does that one specific task really well, but only that task.
Okay, so how do we know that there is nothing similar to that for ETH?
Because I guess currently no one has, I guess, posted about it or said that they've made like this, or like, I think to make like a negligible difference, no one has taken the effort to like manufacture an ASIC for ETH-hash, partly because I think ETH-hash is like the mining algorithm for, or the hashing algorithm is, I guess it's memory bound or something like that. So it's not as simple as computing SHA-256. So a lot of the hashing algorithms that came after Bitcoin, they try to make it more ASIC resistant. It doesn't mean it's ASIC proof. It just means that no one has manufactured an ASIC for it, and probably because it's too costly to do so for just a negligible difference. So that's why GPUs are still used for Ethereum today, and that's why the GPU like market is pretty like out of whack, right? Yeah. So I want to clarify. I guess I want to talk next about Ethereum accounts. So as opposed to UTXOs, because when we were talking about Bitcoin for the first time, it was really difficult to wrap our heads around the idea of like UTXOs or unspent transaction outputs, right? But I want to say it makes a lot more sense to use UTXOs in Bitcoin. And why do I say that? Because the essential problem that Bitcoin is trying to solve is the double spend problem, right? They wanted to make sure that they wanted to make private transactions between different people, and it's really easy to say, here's a spendable UTXO, as in like here's a spendable piggy bank that we create and then we destroy later on, and it's and that's how Bitcoin is transferred between people, as in like you give them a piggy bank or you create a new piggy bank for them, and then when you want to use it, you destroy it, right? So it's really simple in the Bitcoin sense. But when you talk about a validator side, from a validator's perspective, it's even more easy. All you need to keep a track of is a list of piggy banks or UTXOs. Whenever someone wants to spend a Bitcoin, all they have to do is just change, destroy a UTXO and create a new one, right? It's, I guess, at its very core, Bitcoin uses this UTXO model to make it, I guess, as simple as possible, because that's all it needs to do. When we're talking about Ethereum, when you're doing a little bit more complicated things, there's more complex things going on, so we need to write smart contracts that can easily send like ether balances between different accounts or different contracts, right? So it doesn't really make sense to like aggregate all these UTXOs to say, oh, I can send these UTXOs to this address, right? So we need a lot of we need to like keep a lot of data in our smart contracts too, and because of that, and because of these all these fancy things that we're trying to do with Ethereum, they use an account model. So, any questions? Okay, cool. So in Ethereum, there's specifically two types of accounts. So there's an idea of an externally owned account and a contract account. So the thing that we want to get across is that they're very different things, or they're different in the sense that you can lose money if you send money to the wrong account, basically, and we don't want you to do that. So if you create an account, if I create an account, if you create an account that's owned like by a normal person, a normal entity, right? That falls under the category of an externally owned account. This can be owned by a person, a corporation, or like organization, and it's usually it has its own like address to it that you can send money to, and it has its own internal ether balance, so you can keep track of how much money you have, as opposed to like a list of UTXOs, right? Next, when you write a smart contract, that smart contract itself has its own account. So you can think of it as its own like separate entity, okay? They have their own address, they have their own ether balance, but they have extra parameters or attributes, such as they have the code that's associated with the contract, they have storage for that contract, and the main idea or the main difference between the two is that these contract accounts or smart contract accounts, they can't interact with anyone unless you poke it, as in like you try to call a function in the smart contract. So you can think of it as an autonomous agent that lives inside the Ethereum network, and it reacts to whenever you call a function inside a transaction. Let's say I send this much money, X number of dollars, to this smart contract in the Ethereum platform, and I wanted to do these specific actions X, Y, and Z, right? I call these certain functions, and based on those functions, you get some sort of output or you get some sort of functionality. And these calls to the contract will change the network state because it has access to these certain controls. It has its own ether balance, as in the contract itself has an own ether balance. It has its own contract state, so in different stages of your smart contract, it might be in a different state. It has permanent storage, meaning that you have the ability to like write to the blockchain and make changes to the network whenever you want to. And generally, Ethereum smart contracts serve 4 different purposes. The first is they're used to store and maintain data, right? If you want data to write to the blockchain or something like that, you can do that. But obviously, you want to make sure that this data is, I guess, you don't want to store everything on the blockchain. So stuff like your credit card number, your social security number, you don't want to put that on the blockchain because that'll live on there forever, right? Another thing is that it helps manage like relationships between untrusting parties. So this is like the basic idea of what a smart contract is supposed to do, as in like it can hold money in escrow between when someone's trying to do business with a different party, right? It allows you to trust this smart contract rather than this separate entity, and use the smart contracts as a mediator between your transaction, right? The third option or the third function is that it provides like other functionality to other contracts, as in it can serve as a software library for other contracts to call. So let's say I write a smart contract that's supposed to do some sort of mathematical like calculations, and people see that, oh, I do it really well, or I do it in a secure way. They'll use my smart contract, or they'll reference the function in my smart contract and use it repeatedly, right? And lastly, we have complex authentication. So something like multi-sig transactions, as we've seen in Bitcoin, we can do that with smart contracts. And we can also do a little bit more complex things if we really wanted to, because whatever you can think of in, let's say, the smart contract world, you can try to do that in Ethereum. So all of these four different purposes. A smart contract can be any combination of any of these 4. It can be like it can store and maintain data, but it can also do like also be like this mediator for a transaction, right? And this is just like an example of what a smart contract might look like. This is written in a language called Solidity that's JavaScript based. It doesn't matter if it doesn't look familiar to you, or it doesn't look it looks foreign to you right now, but I'll explain it a little bit. So this is like the idea of like a betting contract. So you start off the contract with this heading, and you have two gamblers, so gambler A and gambler B. So let's say me and Gillian are in the middle of a bet. Let's say who is going to win like the Super Bowl or something like that, right? So we have like a list of outcomes, and we have this data structure called the bet, and it has these certain like attributes of a bet. So whenever we create our bet, we would call this function down here calling make bet, and it would probably create this bet in this list of, or this mapping of bets. And whenever this outcome that we get is like decided, this oracle or this trusted entity that will reliably report the accurate truth, like reports his outcome, then someone ends up winning or losing the bet, right? So once we do that, the oracle will call make decision, as in like they'll secure this decision as like the final outcome, and whoever wins the bet will be either me or Gillian, and whichever person wins can call this withdraw function, which allows them to withdraw the winnings that they get from this bet that we create, right? So this is just like an overview of what like an example smart contract might look like. It's written in code or something that looks like JavaScript. Yeah. Any questions? Should I move on? Oh yeah.
So you mentioned before that the DECs are created as that was created. Does that mean that it's easier to deposit that was
Not necessarily. Because in Bitcoin, it makes it easier for the computer to verify like if a valid transaction is, if it's a valid transaction or not, because all it has to do is just ask this this black and white question of is this like piggy bank or is this UTXO spendable, basically, right? It's a yes or no question, and it makes it easier for the Bitcoin network or the people, the nodes or the validators on the Bitcoin network to like figure out if this is a valid transaction or not. In Ethereum, you would do some sort of other stuff with accounts. So like normally, if you're dealing with accounts, you would check if someone has the remaining balance in their account, and then deduct from that if it goes through, right? So there's different ways to do that, but in Bitcoin, when they're dealing with UTXOs, it just asks a black and white question saying, is this UTXO spendable or not? If it's not, then it's not valid. And if it is, then it's you can carry on with this like transaction, right? So it's just the way that the systems are, or the networks are like created, because they use different like ways to keep track of transactions. They have different ways to keep track of like if a transaction is valid or not. Does that make any sense? Okay. So then the last thing I'm going to talk about is the Ethereum virtual machine. So we have this idea of smart contracts. How do they actually get executed, right? So this Ethereum virtual machine is it's what allows like all these smart contracts to get executed on this distributed network, the Ethereum network, right? It's not the contract code that gets directly executed. It's actually compiled down or translated into this EVM code, okay? And it's very similar to assembly language if anyone has taken 61C before. But the idea is that we take this really complex language, human readable language, and we compile it or we translate it into something that's much more simple for a machine to interpret, right? So you basically give the machine like a list of instructions of what to do and what to execute, right? So every validator on the Ethereum network downloads, like say, this software, and it uses this virtual machine to run, execute any of the code that it gives it or that it receives from the network. So the idea is that if my computer is different from all of yours, or let's say you have a different processor than mine, you have a faster computer, I have a slower one, the idea is that we have a standardized way of executing the code or the smart contract, so it gets rid of all these inconsistencies and it makes sure that everyone is able to get to the same exact result, and that's how we get to some sort of consensus or some sort of agreement on like the execution output, right? So that's what the Ethereum virtual machine is. This slide is mainly about the proof of work aspect and a lot of other things that we talked about in Bitcoin. It's not just exclusive to Bitcoin. It also translates over to Ethereum, right? So Ethereum also has like this mining puzzle, but miners they create blocks by executing EVM code rather than validating transactions, right? So so the main takeaway I want you to get away from this is all the stuff that you learned in Bitcoin so far, it has its applications in Ethereum. It's not just exclusive to one or the other, right? Next up is that this Ethereum virtual machine, the coolest part about it is like the compiler aspect, right? It takes all your fancy shenanigans in your smart contract language, and it converts that into some simplistic and deterministic EVM code that's able to be run on all sorts of computers as long as they have like the updated software, right? So that's mainly what the Ethereum virtual machine does. The one aspect or the one issue that we run into is the idea of this. So let's say Gillian is an attacker on the Ethereum network, and she looks at the Ethereum network, right? And she sees there's a bunch of computers just waiting to execute some arbitrary code that a stranger puts online, right? So she can be like, okay, I have a lot of power in this network. I can just submit this while loop that loops forever. So this infinite loop that will keep on running and then jeopardize the entire network, right? This is really bad. Everyone would be stuck on this. Everyone who's trying to like run this EVM code that that gets compiled, they would be stuck running this this infinite loop, and they don't know when they'll ever exit, right? And this is really bad. So this contract we see here never really terminates, and it could lead to this idea of a denial of service attack, as in it basically halts the entire Ethereum network. And if I really wanted Ethereum's network to go down, all I have to do is just send this piece of malicious code, and boom, everyone is in danger. Everyone's running this infinite loop. So that's not very good. And if you've taken CS70 before, there's this idea of the halting problem, where you don't know if a program would ever terminate unless you run it, actually run it for yourself. So this is a problem, and we need to solve it somehow, right? So this is Ethereum's solution. It's pretty neat. They use an idea of what's called gas. So it's paid for using Ether. So whenever you poke a contract and you want it to do something, you have to feed in some gas, or you have to feed in some fuel for the EVM to execute your code. So you need to specify this idea of a start gas, which is like the maximum quantity of gas that you want your function call or your poking the contract would take up. And then you have this specified gas price, where this is basically just the conversion factor from Ether to gas, because Ether fluctuates a lot, as you see in the daily markets. We wanted to make sure that we know that we're paying some sort of decent amount for computation or execution of our smart contract. So we have to specify both of these attributes, right? So basically, what happens when you put in some gas to execute a function is that this smart contract, if this smart contract executes all the way through, and you didn't use up all your gas, whatever's remaining in your whatever remaining fuel you have left is refunded back to you, basically. So whoever's calling the smart contract, if their gas isn't used up, they get refunded with the remaining gas. And let's say if we tried to do this infinite loop, like we tried to carry out this infinite loop attack, right? At some point, the program is going to terminate, or we're going to run out of gas, because we'll run out of gas and the program will terminate, and that will actually revert the changes that the contract tried to make, and also revert like the network state, basically. So whatever attack you tried to carry out, that would get undone, and on top of that, you don't get your I guess your gas that you fueled into your contract returned, because the idea is that someone had to do the work to execute the EVM code, and once that gas is spent up, it's proof that someone actually tried to run that program, and you don't get that back ever. So, so if you ever wanted to launch an attack, as mentioned before, you basically need a lot of money to carry out such an attack, and you won't even get your money back if it ever terminates, right? So you can think of gas as the price that you have to pay to use this like distributed, trustless, decentralized computer, right? Yeah, and whoever is trying to like carry out a DDoS attack would need a lot of resources to pull this off. The last thing, or close to the almost last thing that I want to cover is the Ethereum network state. So we can think of the Ethereum network because it has like all these fancy like capabilities. We think of it as like a state transition function, as in we start off with some initial state with all like the accounts in this network with their respective ether balances and all the smart contract code. We feed it like the block state, the gas, the memory, the transaction that we want to send with it, the message, and a few other like technical details. And what it spits out is that it spits out a new state with like the remaining gas. So this is just pulled from the Ethereum white paper. It's just stating that the Ethereum network just transitions from state to state to update like smart contracts and update account balances and whatnot. Does that make any sense? Okay. Lastly, I want to like a few conclusions about Ethereum is that Ethereum is not really meant to be efficient, right? It's actually redundantly parallel, as in all these nodes in your network or all these miners in your network, they're running the same code over and over again, as in each person's running the same thing. It's not really there for an efficient computation, a way to compute something. It's mainly an efficient way to come to agreement or come to consensus on some agreed upon network state, basically, or execution state. So when we think about this, it creates an incentive like not to use a blockchain, as in this is really expensive if you think about it. But the reason why Ethereum uses this, it's for these nodes in this network to really come to an agreement on some sort of shared execution state and come to a consensus. It's not there to compute some value in an efficient way. And with that, does anybody have any questions? Yeah.
Does the gas get burned or does it go to the miner?
So whoever's running the smart contract, they'll get rewarded with the gas. As in they'll get the gas and it's basic. You can think of it as like the transaction fee, but it's not really the transaction fee. The transaction fee comes in more in the mining aspect, but when the person who's executing your I guess you basically pay this gas to have the Ethereum virtual machine run your program, basically. Yeah.
So to launch an attack, is it always be reverted, or is it like is the way to not be able to revert the execution?
So the idea is that if a smart contract doesn't finish executing before the gas runs out, right? It means that it either took too long, or it was probably a malicious attack, or it's just one of the combination of those two, right? And in those cases, it usually means that something like bad is happening. I think the protocol determines it as some sort of bad thing happening, and so it actually reverts it back to the previous thing before like the smart contract before the smart contract starts executing. So let's say I carry out this infinite loop, right? But in each iteration of this loop, I deduct like 10 ether from some person's account or something like that, right? If it keeps running and I run out of gas and the execution stops, I shouldn't be able to withdraw all that ether from this person's account, right? It needs to go back to like its previous state because that was its previous valid state. Does that make any sense?
So you can always go back to previous states.
Yes. Yeah.
So the price of the gas is determined by the I'm the say the creator of the smart contract, I want to write the smart contract as complicated as possible, right? Because in this way I can get more gas, and that gas will convert it into my model.
So that's not exactly how that works. It's the person who writes the smart contract or puts up the smart contract, he doesn't get anything. As in, like, yeah. So he doesn't get anything from that. The gas that you pay is basically paying for the execution of the smart contract, but the person who wrote the smart contract or deploys a smart contract, they don't get really anything out of it, as in, like, but they are like the sole owner of the smart contract.
Yeah, but there's the problem of so you have two smart contracts, like they are the same thing, because their implementation is different, and like one smart contract is it costs less gas than
Then the person who is trying to use, so you're saying that these two smart contracts do the same thing, but one might take more gas, one might take less gas. So it's up to the user who's calling this this functionality. If they want to save money, they'll call the one that saves them the most money, basically. Like, it's the person who ends up wanting to execute a smart contract, they pay for the execution. As in, let's say you write a smart contract that lets me add 1 + 1 or something like that, right? If I want to use that functionality, I would call that, right? I would have to pay money to call your smart contracts and I guess compute this value of 1 + 1. Yeah.
I kind of have like a general question. Why would you want to use like Ethereum? Why would you want to run your code on Ethereum when you could just run it like on your local computer or something?
So if we go back to I guess this idea of like this distributed network, if you have I guess a trustless environment, as in you have intermediaries that you don't really, you have parties in this network that you don't particularly trust, but you still want to do like you want to, form a relationship with them, as like you want to do some sort of, you want to form some sort of agreement between, let's say, party A and party B, right? In this like network of without any trust, without having to trust this other party, the Ethereum network using smart contracts allows you to like facilitate this like business or this transaction. If you're doing it on your own computer, I guess you have to place your trust in the person that you're doing the business with, right? As in, you might need a middleman to do that for you, or if you're doing it with this person directly, you have to place your trust in them. In the Ethereum network, it removes that sort of trust by having you trust the network or the protocol, and that does the logic, and that does that carries out the agreements between you two, or it enforces the terms of agreement between you and this other party. Does that make any sense? Yeah.
I'm a little confused on how the actual Ethereum blockchain looks like. So in Bitcoin, you have a market tree that's summarizing each transaction.
Mm-hmm.
Is there also a market tree in Ethereum, and what is a summary?
So it's not exactly called a Merkle tree, it's called the Patricia tree, because you're keeping track of not just transactions, you're keeping track of like a bunch of network states. It's a little bit more complicated, but the idea is still the same, as in like you would still have some sort of like tree structure or some sort of root that maintains all your, attributes of the layers below it. So it's called the Patricia tree. It's not essentially called a Merkle tree. I can show you afterwards if you come to me after class. Yeah. Everyone good? Let's take a 5-minute break. Yeah. Oh shit. Is that okay?
You did that. It's good.
I think if I had a script, it makes it easier for me to like do something.
You still use a lot of filler words. And you can also end every sentence with right. Which, like,
Oh. I mean, I didn't realize that.
No, it's totally fine. But like, you did a lot better. Like the voice. Good job. Hey. It's
The lecture, lecture 30, like the
yeah. So if you go to the regular attendance form, the code word today. If you go to the regular
I
attendance
think
form,
we might
the
have
code word today is
changed it. I think we might have updated so it's now public. If you want to check again, if it doesn't work, come to me again, and then I'll figure something, or I'll tell whoever's in charge of listing the YouTube videos to change them. Okay?
Okay.
I think we changed it like recently in the past like few days.
Oh, cool, gotcha. And then are there is there a link to
Can I help you?
for the next lecture? I can't like wait so I get
The
I'm sorry?
lecture
I
2
can
actually
translate.
didn't
Okay,
get
yeah, so the attendance link is the same as it usually is.
First of all,
The code word is
battery
vitalik.
What is
camera,
usually
and then the screen recording didn't have mic.
blockchain.berkeley.edu/decal/attendance.
Thank you. And what was
As in, like, that's put on
Vitalik.
the lecture. We don't have the what's it called.
Are there any links like last year?
Yeah, you can. If you go to the you know the website.
Yeah.
Yeah. So the website, if you just instead of clicking for our semesters,
Yeah.
click the previous semesters
Okay.
for fundamentals.
Okay.
Click lecture 2 for the history,
Okay.
and then that will have the lecture.
Okay.
Thank you. Cool.
Come off with like a bit of dumb questions. I don't know anything about coding. But you mentioned part of the reason for smart contracts is that you want to avoid like ambiguities for like languages and stuff like that. But is there any ambiguity that ever arises from coding itself, or is it avoidable because there's always like an end result?
Hi, how can I help?
Yeah, so this is about the class logistics. So last weekend I was at the Berkeley bootcamp. So am I excused from like
As long as
absent?
you make sure your TA knew that.
So
then
Oh,
it
make
should
sure
be
my
fine.
TA knows that?
Yeah,
Okay.
because your TA is in charge of your grade book.
Okay, sure. I'll do
contract, you have to define it in a very specific way. And that's like I guess what allows for the smart contract aspect, because this allows the machine to like I guess interpret it one way and one way only.
Yeah.
And it's deterministic, as in every time you run this smart contract, it will always give you the same result. And that's what you're supposed to do. Yeah, so that's the idea of the code aspect, as in you can't really do anything ambiguous in code because otherwise the machine won't even know what you're trying to do. And then, if your machine can't determine what you're trying to do, then it will never.
Right. Okay, that's what I figured.
Yeah. So the idea is that your code or your smart contract is very specific. It should be very specific. But I guess when you're trying to translate, let's say like a Google contract to a smart contract, it's a little bit difficult because it's as in you might not be sure like what exactly what you want your smart contract to do specifically. But
Right.
so
like a
it's not
translation kind of-
it's not exactly technically the smart contract aspect is not really like it's kind of a misnomer because it's not really a contract, but it's like it's basically like a list of actions that you can do in like a trustless manner, as in like if I wanted to love that the contract that I should love, like that allows us to do it in a trustless manner even though we don't trust each other or something like that. And it's like a network of unknown users.
I guess a good follow-up question to that is like since it's pretty deterministic, anyone should just be able to look at the code and know exactly what's going to happen with different outputs. But would it be possible to like kind of make the code confusing for some people trying to kind of like mislead something about what would actually happen?
I mean, there's always ways to make all code bad, but if the machine is able to like know what it's supposed to do, as in like if it always like if the machine, I mean, I'm gonna say that you can make your code like as bad or unhuman as possible, but I guess something will actually think of it as migration.
Okay, let's get started. So we're going to talk about use cases now, and hopefully this is something that you guys have been thinking about as well on your own. As we learn about the blockchain, you hear about blockchain in the news a lot perhaps, but trying to understand which of those use cases is actually a good idea is something that's hard to teach, but we'll try. So just some basic use cases. So we talked about Ethereum. Oh dear. We talked about Ethereum, and we talked about how it's this decentralized app platform. It's this platform for handling this functionality that we've given smart contracts, and so one can plug in your own basic logic and make essentially whatever you want to happen. So some basic use cases is like this token system implementation. So if you think about Bitcoin, it's really not that complicated. You check whether or not Alice has enough money, and then that she started the transaction she's trying to start. You subtract the money from Alice and you give it to Bob, right? That's like relatively simple. We can describe it in a couple lines. And in Ethereum, we can essentially write all of Bitcoin in literally 4 lines. So that just kind of gives you an idea of how far this space has come. It's kind of cool. This example is from the Ethereum white paper. Does this make sense to everybody? The fact that we can do this? Cool. Okay. So this thing is called Namecoin. Namecoin was the first fork of Bitcoin, and it was the first one to implement something called merge mining. It's a decentralized DNS system. So DNS stands for domain name system, and it just maps a domain name to an IP address. So if I typed in Gillian.chu and I wanted this to be my domain name, I could map it to some IP address. And I could do that really easily on Ethereum. So just to give you an idea of like sort of the applications that are possible, and this is what people decided to use it for. Okay. So another option or another example we'd like to bring up is this idea of document ownership. So if you recall with the blockchain, we have this sort of idea that we can verify the integrity of something that we've saved onto the blockchain. We also have proof that something did happen at any given point in time. And so we can hash a document and store it on the Ethereum blockchain and then verify the integrity of it. So see, it says proof of existence. So I can do things like verify that I own a document because I have a certain document and I don't have to reveal the document in order to prove that I own it, because I can point to some point in the blockchain in the past and show that, look at this point in time, it was the ownership of this document was transferred to me. So another use case is I could use a smart contract to rent service space to other people to store documents. So I can free up some space on my computer, store documents for people, and earn money for that. As long as I can prove the document is unmodified and that I'm storing the document, then I can earn some money. And so smart contracts would facilitate that in just a few lines of code because it's this agreement that between the two people who don't have to trust each other. Does everyone like sort of appreciate that? It's kind of cool. Like with one smart contract on the Ethereum blockchain, you can run an entire company. Yeah? Okay. So the way exactly that you would prove the document is unmodified via hash values, that's essentially, think of a user asking you to hash the document that you're saving with some random number that they pick, and then they're going to compare what you should have saved. Like they'll compare what your hash should be with what the hash you're going to return is, and it'll just prove that you have the document that you say you do have. Okay. Yeah. Question.
So in this particular example that you gave with storing documents, what role does the smart contract play versus the server that's like a centralized server that actually saves the document?
Okay, so the question was what the role of the smart contract is versus the centralized server. So the centralized server is not so much like, don't think of it as centralized, it's just if I want to have somebody save some documents for me because I don't want it on my computer and I have like lots and lots of files. I want somebody to save it for me. I can use this smart contract to save it in a decentralized manner rather than saving it in one centralized database. And so because I can do that, there is some there's like the value in that in saving it in a decentralized manner is that I wouldn't have to trust one company to store my document, and it's more likely that if I query this decentralized network, there's not a central point of failure. Does that make sense? Okay. Any other questions? Yeah. Great.
Yeah, I was just curious about like the difference between like storing documents on a decentralized network versus a distributed network, but using like access protocol or something like that.
Okay. So
Yeah.
your question is about Paxos?
Yeah.
it's not necessarily that there's a difference, it's just being able to facilitate that with the smart contract. Okay, so I think there was an earlier question about Denver. So in this space, we have a lot of like hackathons. Because the space is so new, people sort of, they host things like this where you get a lot of coders and a lot of ideas people together, and you try and build out as much as you can over a weekend. So Brian and I, you might have noticed, we're not here last weekend because we went to Denver to attend this hackathon. And so we built something called we built a Google Chrome extension that was essentially worked with a smart contract that exists on the Ethereum blockchain that's called standard bounties. The idea is that you can pay people to answer your Stack Overflow questions or your Stack Exchange questions with Ether, and they'll answer like with a better answer, or you can upvote people. Anyway, so it's incentivizing answers, but that contract is just a standard bounties contract. So you can file a bounty for anything, and we just provided sort of an interface to work with that blockchain, with the smart contract that's saved on the blockchain. So does that make sense? A lot of the applications out there aren't even necessarily just writing a new smart contract per se, it's finding new ways to interact with the ones that are out there. Yeah?
So say like it would be like if you posted something already and you got a bunch of upvotes, then they would pay you for that? Or?
So the original poster, the OP would come back, and if they really liked your answer, they could reward you some of the bounty. But if you had a MetaMask account, you'd be able to see all the people who had posted questions and like had bounties associated with them, and then you could go back and like try and earn some money by answering questions well. Yeah. Okay, makes sense. So this is sort of a good, this is sort of a good use case just because it's clear that like you can incentivize people to do things. It's transparent, so you can see all of the questions that exist out there, and you can very clearly, like, it's a very simple, like, I want an answer, and this is like what will fulfill it. You had a question?
Yeah, so how many like smart contracts are there on the Ether network so that you can build on top of different applications?
How many smart contracts are there? A lot.
Like
Unique smart contracts.
you can build on top of like,
So you can build on top of any smart contract, really. If there's a smart contract out there, or if you want to build your own smart contract and push it onto the blockchain, and then build like another thing on top of that, that's totally valid. In terms of numbers of smart contracts, though, I mean, I don't have like a solid number for you. Sorry.
Sorry, I just want to make sure I understand what this is doing. So
Sure.
essentially, the reason this is any different from maybe a website saying, okay, these are all the bounties available, and
Yeah.
you know, these are the good people who actually pay off. It's just that we don't have to trust that centralized website because that website could be lying, right? That's the idea here.
So the benefit of this is that it also makes sure that people have the money to put up to pay you that they're claiming that they do. And the thing is that if they don't come back and sort of like agree on their side, if the OP doesn't come back, then it'll pay out into an escrow account because smart contracts execute immediately, whether or not there's fulfilled. Like, so you have to account for that case, and whatever happens, like, it'll happen, right? So it's just sort of definitive. All right, let's move on. Okay, yeah, so this is just sort of the bounties network. That is, we'll talk a little bit about this a little bit more, but sort of you can see this is the Stack Overflow post, and then you can click on that, and it'll take you to this page where you create a new bounty, and you upload and you put in your MetaMask address, which if you guys aren't sure what MetaMask is, it's just a browser, another Google Chrome extension that allows you to, it makes it easier for websites to accept Ether and stuff like that. So yeah, so then you can see all of the bounties that exist on the network. So those are all existing things that are functional. Okay, so let's move into some advanced use cases. So again, we're talking about decentralized app platform. You can plug in your basic logic, but we want to see sort of the broader things, like what has been proposed at maybe a government level. So this is something that is sort of interesting. So as we know, it can be difficult to trace ownership of land, especially as governments are overturning. And so if you have some flawed paperwork, forged signatures, if you have governments that are constantly like being overthrown, the military keeps taking over, it can be very unclear who owns what land, and because there's this lack of central government authority. And so in these cases where there's a lack of centralized, like a lack of trust in central authority, we can have perhaps a good use case for blockchain. So those are some pitfalls that with current solutions, citizens might not trust an NGO to keep track of their land. There might be multiple NGOs. NGOs also have a habit of sort of disappearing sometimes and coming back later. And government might not be able to support it. You have corrupt officials. So the blockchain solution in this case would be to hash the land title and store that on public blockchain so that it's transparent. So because it's transparent in the blockchain, you prevent some confusion and some fraudulent claims because it's either there or it's not. And the immutability prevents the forgery of signatures. So we can't exactly overwrite information that is already on there. And then it limits centralization as well. So there's no need for government offices, you don't have third-party intervention, and conflict is minimal-ish. But does that sort of make sense to everybody, why there's like a decent use case? Yeah.
Well, so typically, if you lose your Bitcoin private key, then you just lost some Bitcoin. Here, if you lose a private key, you've lost your house.
Okay, so that's a little different because so we like to say that the blockchain is only as good as the information you put on it. So just like this is a thought experiment, right? So how exactly would you set this up in such a way where people don't necessarily just like, if I lose my private key, I've lost my house. That's pretty awful. We want to make sure that like perhaps then we have, like perhaps that's not necessarily a blockchain problem. Perhaps that's more of a user interface problem and how exactly we interface with it. So maybe you set up an NGO to deal with that. I don't know. Yeah, okay. But does this make sense to everybody? Like why this is a use case that has been proposed? I'm not saying it's necessarily a good one, just it's a use case that's been proposed. Okay, so these are some countries that have looked into doing this. So you've got Georgia, Ukraine, Sweden, and we like to talk about how you have to trust that the information fed into the blockchain is correct. And so it can be very tricky to associate virtual identities with land. So how exactly do you use satellite to keep track of like land, and where do you keep track of, anyway. So there are some problems with this. And that's something that you should think about, like decide for yourself whether or not you think this is a valid use case given all of the problems and the caveats. But any comments, questions on this? Yeah.
So you would create like a smart contract saying you own this piece of land, and then that would be contained on the distributed network, so they can go and just take it from you and you prove that it's yours.
So this wouldn't necessarily be a smart contract, right? This is just making use of the blockchain to store at some point in time, I can prove that ownership was transferred to me. So we don't necessarily have to even talk about a smart contract. Maybe you would write a smart contract in order to generate those like transfers of titles or whatnot, but all that we're really making use of is the fact that at some point in the past I can say the ownership of this part of land was transferred to me, and I can prove that because it's in the blockchain and everyone can see that, and we've all agreed upon that. Does that make sense? Okay, cool. So just take some 2 minutes and talk to your neighbors about why exactly this has been proposed as a blockchain use case and why you think that is.
Although people have to trust it.
Okay, can I bring it back? Okay. Are there anything that was super revolutionary that somebody heard from their partners? Cool. Let's move on. So to talk about this next use case, I sort of have to define a few terms. So does anybody know what a prediction market is? Raise your hand. Nobody knows? Oh, okay, some people. So a prediction market is something that draws on the wisdom of the crowd. So market makers would create an event, such as who will win the 2020 presidential election, Zuckerberg or Trump. And so events must be public, they must be easily verifiable, and they must have some due date, right? Something we expect to happen. And then essentially the way this works is participants buy bets on whether or not they think Trump or Zuckerberg would win, and they'll pay a small fee. So they'll essentially buy some shares or buy a bet. And the bet price will accurately represent the best predicted chance of that outcome occurring. So if people think it's super likely that Zuckerberg is going to win, it's going to cost a little bit more to buy a Zuckerberg share, understandably. So on election day, random oracles, which are just sensors on the network, will report back on who won. So oracles who voted with the majority will collect a fee, and that's how you verify that you incentivize these oracles to vote correctly. And then shareholders who voted correctly will also cash out on their bet. So if you voted correctly and Zuckerberg does win, then congrats, you have $1. So does that make sense? Like, this is sort of what a prediction market is. So there's some advantage for if you have insider information, you can make some money based on like betting against it and then betting, cashing out on the other side. Does that sort of make sense? If I know extra information, I can take advantage of the situation. Yes.
So 2 questions. One,
Go for it.
is this just sort of getting around like insider trading? If you do it using, Ethereum, then you can be a part of insider trading.
So I'm not saying necessarily this is just like a concept. Like a prediction market is something that exists in other countries. It's technically illegal in the US for insider trading reasons. But the question is whether or not we can use this on Ethereum. And they'll vote on things like whether or not it's a valid sort of event that you're voting on. Yeah, go on.
So the second question is just about the escrow accounts. So you said there are going to be escrow accounts, but someone has to own these, right? I mean, how do these accounts get created? Who owns them? Where are they? How does that?
So I didn't necessarily, so specifically for the prediction market, so an escrow account doesn't necessarily have to be owned by anybody. You can have that inside the smart contract. So the smart contract itself is technically sort of something that can hold money, and so that's something that's different. That's something that's special about a smart contract, is because you can put money into a smart contract and then cash out from the smart contract. So it's this third entity that you don't necessarily have to trust, and everyone can see. It's very transparent. Okay, cool. So you can maybe see the advantage in having a service that never crashes. Previously here we had an example of a centralized prediction market, something called predicted.org. It's used for sort of politics and stuff like that, because who wants to know the Arizona 8th District? But a service that never crashes, a service that's completely transparent, that seems like sort of, if that's what you want for a prediction market, that seems like a perfect use case for blockchain, right? Because there's some buzzwords that we keep hearing. But again, so prediction markets, note, according to the Commodity Futures Commission, this is illegal in the United States, right? So while there are benefits to being decentralized, this is like something to keep in mind. And then second of all, there are some caveats that come along with what is seemingly a perfect use case. So no restrictions on market creation. But you then need a defense against unethical, illegal markets. So for example, Gnosis and Augur, those are both companies that are looking into sort of building prediction markets and then finding ways around how to make sure that they're not doing anything illegal. So the way Augur gets around having unethical and illegal markets is they have oracles vote on what is considered unethical or illegal. So you don't want to have people voting on like if you create an event, for example, that you want to kill somebody and then you bet heavily that it doesn't happen, then you see how this could become problematic, because if somebody did kill that person, then they could cash out. So you don't want things like that to happen, right? So you have oracles that vote on unethical and undecidable problems. But another benefit is that you have a shared liquidity pool. So what that means is there's no reason why some market can't exist in multiple countries, but right now it doesn't. So you should be able to have like a global sort of betting market to see, oh, what's the global opinion on this next movie or something like that, rather than having one in America and one in South America and one in China and something like that. So you have this shared liquidity pool that sort of gets around that. And then you have censorship resistance. So censorship resistant just means like censorship resistant. Automatic trustless payments, that's the benefit of having smart contracts. Okay, so this is prediction markets. Make sense? Okay, so if we talk about one use case, this is sort of a cost-effective way to buy information. So now that we've defined a prediction market, we want to come up with like a question to pose to our prediction market. So, for example, will this movie be a flop? So you want to incentivize the Hollywood insiders who have a lot of this information to give you the right answer. And so you might go to a prediction market, because if you bet heavily against some things, it will create an incentive for somebody to cash out and therefore sort of tell you the right answer. Does that make sense? Okay, so some other use cases, hedging and insurance. So you could perhaps do insurance on a prediction market. So imagine fire insurance as a bet that your house will burn down. Not something everybody wants to bet on. But if you create a market for whether or not your house will burn down, that's essentially what the insurance company is doing, right? They're betting that your house isn't going to burn down, but then if your house does, they will pay you. So if you create a market for, is my house going to burn down, and you vote yes, then you will receive compensation if your house actually burns down. And there's no central intermediary required. Like, there's no insurance company to go through now, so it's cheaper. Okay, does that sort of like, this should be kind of cool, right? That's, okay, cool. So security bug bounty, same sort of idea. You want to incentivize, create a financial incentive for somebody to not exploit the vulnerability that they just found in your company. So, Augur actually secures their code this way. They have this event that's, will someone be able to steal the money in this prediction market? And if somebody does find it, they can only cash out if they bring up that vulnerability in such a way that doesn't, like, not while it's in production. Does that make sense? Like, it won't actually hurt the company. Okay. And then ICO signaling. So perhaps hopefully we've talked about this enough that you are sort of wary of ICOs. And you know that ICOs don't always follow through on what they claim they will do. But ICO signaling could be a useful use case for this. You can put your money where your mouth is, right? So you demonstrate commitment, and you will have some sort of significant financial loss if you miss your commitment. So if I bet heavily that my product will launch on time, then I lose a lot of money if my product doesn't launch on time. But this is something that we don't see a whole lot of ICOs doing because they're not fond of losing a lot of money. Okay, any questions on this? Cool, okay. So one last interesting note is something called futarchy. Does anybody know what futarchy is? You define futarchy. No one knows what futarchy is. You're not paying attention in government. Okay. So futarchy is a form of government proposed by the economist Robin Hanson, where elected officials will propose, will define and then manage national welfare, but then prediction markets are used to determine the policies they believe will have the most effect. So essentially it's like they found another way to do democracy without all of the representatives in the middle. This is something that's shaping the way people think about DAOs, decentralized autonomous organizations, and this is something you have a lot of people in government quite interested in. But yeah, so these are just all examples of articles. V. Buterin, that's Vitalik Buterin, cool. Just some guy. Yeah, so this is just sort of why we study cryptoeconomics, and this is why people are interested in government, or one of the reasons why people are interested in using blockchain for the government. Any questions? Yeah.
Won't the government be against this because it takes away the power pretty much?
Yeah.
Every single law.
Yeah, it's not super fun. Like, I don't know anybody in the government who's super fond of this idea particularly, but it's an interesting proposition, and it's an interesting use case for blockchain. Cool. All right, any other questions? No? All right, okay. So does anybody know what a blood diamond is? Cool. Somebody want to give me a definition? Cover.
All the diamonds are mined in Africa, like poor people just digging through the sand, hoping to get diamonds.
So blood diamonds is more specifically conflict diamonds. So you have wars fought over it. If these diamonds have been traded for guns or stuff like that, it's been associated with violence and stuff like that. People sometimes are hesitant to buy that diamond for their wedding ring. Go figure. So the Kimberley process is this government effort that requires participants who are selling diamonds to certify the origin of that diamond. And so this is sort of a unique use case for blockchain, just because you want to be able to trace a diamond from its origin to when it ends up in the shop. And so if you can record an irrefutable digital footprint of the diamond and you put that on the blockchain, you essentially tokenize the diamond, and then you maintain a complete history of the diamond. So does anybody see how this is sort of a supply chain use case? And while we're not usually a huge fan of supply chain use cases, this is a unique one because it's well suited. You need auditing and analysis, and you need the ledger history to be immutable, cryptographically secure, open, and transparent. And Everledger, which is the company that does this provenance of diamonds, so finding the origin of diamonds, it's hard to counterfeit a diamond, and it's hard, but it's usually, okay, so one reason that we don't usually like supply chain cases is because it's hard to prove that the token on the blockchain corresponds to the actual good in the physical world. But diamonds especially, Everledger sort of takes the optical fingerprint of the diamond, and so diamonds have this special quality where they have they're all unique crystalline structures or something like that, and so you can take a fingerprint of a diamond, which is why you can do something like this. But in general, it's quite difficult to correspond that token on the blockchain directly to a physical good, and that's why we're sort of wary of supply chain cases, because that cross-validation of information can be difficult. So remember, again, that the blockchain is only as good as the information we put onto it, and Everledger has to trust the entities that are authenticating those diamonds. You have a question?
Yeah, does Everledger have any competitors?
Not that I know of. I don't pay a lot of attention to the diamond market, though.
Yeah, I was wondering, how
Yeah.
do you see this space evolving? Do you see it becoming up to the original diamond owner to place the record on the blockchain, or do you see it becoming more of a responsibility of a third party such as Everledger or other companies?
So I think the way that it currently works is Everledger provides a service, and companies that are looking to, I don't know any major diamond companies, but companies that are looking to prove that the diamond has come from an okay source would go to Everledger and find this way to provide this sort of history that you can authenticate. Does that make sense?
Yeah.
Okay, so I don't know that necessarily it would be up to people to do it individually, but I could potentially see it moving towards that. I think it makes more sense though for a large company that's selling copious amounts of diamonds. Yeah, okay. Okay, let's move on. Okay, people should know what a smart energy grid is, yes? Okay, so essentially what it is if you have an energy market where House A has excess heat, House C lacks heat, and House A decides if they want to sell their heat to House C so both parties can save some money, but they go through House B, so you need some sort of custom infrastructure for that. So if you create a Ethereum smart contract for financial commitments, this is sort of the use case. And so how that would work is the central entity like AT&T or the government doesn't really have an incentive to go in and help you build this custom infrastructure. But households can coordinate to build infrastructure even if they don't trust each other. So let's say House A and House B have some sort of feud and they don't get along. But if House A decides, I'm going to put in $5,000 into this smart contract, and if House B also commits $5,000, the total amount will go to this contractor that we've agreed upon, and it can only go to this contractor. And in this way, you can collect $10,000, the necessary amount to build that sort of custom infrastructure so that House A can sell energy to House B and House C. Does that make sense? So this abstracts away the need for this third party, and the smart contract takes upon that role. Any questions? Cool. Okay, and then one other use case, after hours trading. So you might have heard why finance is rather interested in blockchain. So one way that we've thought of that you can use blockchain in finance is tokenizing shares of stock. So right now, after hours, the brokerage sort of shuts down, and you can only do limit share trading. And that's just because of regulation, because after hours it becomes very volatile. However, so blockchain, also another caveat, blockchain applied to finance is generally challenging. I think we talked about this in previous lectures where because there's generally some trust between the companies, there's not really a need for this trustless network. this network where there is no trust, right? So in this case, however, you have several brokerages that need to be incentivized to work together in order to allow their customers to take out stock and trade after hours. And so if you convert stock to a token, then this user can sort of withdraw and trade stock tokens instead of actually trading the stock itself. And so when they come back in the morning, they can just resolve everything, but according to the whole history that happened overnight. And if you have all the brokerages share this sort of, if they all share this, the stock token, then you can do the same thing across multiple brokerages. And in this manner, you can allow after-hours trading. So, and especially in this case, the stock token would be backed up by actual stock that the brokerage owns. So it would be sort of a unique use case. Does that sort of make sense, though? Yeah. So this is just like some broad examples of the ways that people are moving forwards with blockchain in various spaces. Okay. So no questions? Okay, cool. Yeah, go for it.
Are there any coins that emulate stock coins today?
Not that I know of. Yeah. Okay. So blockchain versus the internet. The point here is just that we'd like to point out that for the first 20 years of the internet, there was not very many use cases. So we're only about 9 years in with blockchain, and we've come up with some interesting use cases already. So privacy-oriented systems, distributed databases, low-fee financial transactions, cryptocurrencies. So while some of these might sound, and we've also sort of torn down some of these, it might sound like there isn't a whole lot there, but I think in another 10 years, you'll see some pretty cool stuff because there needs to be some time, some incubation time with this new technology. Okay. So just some final notes on the state of the ecosystem, because somebody asked about the hackathon and because we sort of have some comments about how you can get involved. How many people recognize at least one person up here? Should all have your hands raised. Cool. Okay. Can anybody tell me an interesting fact about Vitalik Buterin? Does anybody know who Vitalik Buterin is? Okay, yeah.
I think he dropped out of college. And, he was born Russian but grew up in Canada.
Yeah.
And he created Ethereum when he was white paper when he was 21 years old.
Yeah, okay. So he dropped out of University of Waterloo in Canada because he started working on Ethereum and it worked out for him. So Vitalik is right now 24 and he works all the time. He's super hardworking and he's a genius, not just in CS, but I mean this guy also taught himself Chinese. So, something that's interesting to know about him though is he represents sort of a point of centralization behind Ethereum. So he's a cult of personality and a lot of people really like the guy, but it's also he is what drives Ethereum forward. And people are worried that because it's just this one person behind Ethereum, what happens if he decides to step aside? So that's something that you guys should think about because that's something that concerns a lot of the people in this space. Roger Ver. Anybody heard of Roger Ver? You again, go again.
He was an early investor in Bitcoin. He found out about it like 2009 or 2010, and he bought a lot of Bitcoin and spread the word around the world.
Yeah. So Roger Ver, his nickname is Bitcoin Jesus because he was the first person to really start investing in Bitcoin startups. He, fun fact, really enjoys something called voluntarism, which is just that he believes all forms of human association should be voluntary. I don't know. So he's a huge proponent in the block size debate. That's something that you'll hear a lot of people maybe not like Roger Ver that much or really believe in Roger Ver because he's pretty vocal about the fact that he thinks blocks should be bigger. And so that's not a huge, anyway, I'm not going to comment on that. And then more recently, he has decided that buying up Bitcoins is no longer his passion, and he believes that Bitcoin's not going places and that altcoins are the future now. And so he's been very vocal about that on Twitter. Okay, Nick Szabo? Yes. Oh, okay, never mind. Do you have a question?
Like this for user.
Wait, sorry, what? Okay, never mind. So Nick Szabo did some research in digital contracts, digital currency. He designed Bitgold in 1998, and he was the first one to coin smart contracts. So I think Brian said that earlier. So yeah, he's an interesting person to read up on his past blog articles because he's been in the space for a really long time. And you go back and read some of his earlier articles, you can sort of see the progression of Bitcoin and blockchain. Mark Andreessen.
So he created Andreessen aerobics, which is one of the main PC in the Bay Area.
Yeah, exactly. So for those of you who didn't hear that, Mark Andreessen created Andreessen Horowitz. He also created the first web browser, Mosaic. But yeah, he also runs a very successful firm, and he wrote a piece for the New York Times called Why Bitcoin Matters. So also a very influential person. And then Andreas, I can't pronounce that. Andreas, anybody know this? Yeah, perfect.
He's the best speaker on Bitcoin and blockchain technology by far.
Yeah, so he's pretty great. He actually wrote the textbook Mastering Bitcoin, and he's appeared many, many times on the Joe Rogan's Experience podcast. He's famous for coining the term Internet of Money in reference to Bitcoin. So all interesting things. But yes, so these are all people that you want to get to know to stay in the space. But yeah, and then you guys might have heard of, yeah. Oh, Bobby Lee runs, sorry, oh man. He runs BGTC China, and his brother Charles Lee is like big in the Bay Area. They both run like very successful, very highly involved in the Bitcoin space. Yeah, my bad, thank you for calling me out on that. Okay, so how many people here have heard of consensus? Okay, so consensus is sort of this. Consensus actually stands for consensus, spelled normally, systems, and it's this blockchain software foundry created by Joseph Lubin, so that's also a name you should know. But essentially, they help to develop a variety of applications which operate on the blockchain. So they coordinate between different companies, they incubate, they accelerate, they spawn, all of these spoke ventures. And so you see MetaMask up there, which I was talking about earlier, as a browser plugin that would allow you to use or accept Ether. It makes it easier for people. Gnosis, which we talked about earlier. Uport is identity management, and Truffle is, if anybody is cross-enlisted in the developer's decal, Truffle makes your life a whole lot easier when you're trying to code. But yes, okay. And then these are just all of the companies that, like, all the spokes that they are working on. So I would recommend going to look this up and being vocal in the community of whichever one that you're interested in. So Brian and I worked on that project with Bounties Network that's up there at the top, and they gave a talk this week, hosted by Bab. And so MetaMask is up there, Uport's up there, Grid is a smart energy grid thingy, Infura is hosted Ethereum node cluster, lets your users run your application without requiring them to run their own node. And you might not be familiar with Infura, but if you've ever interacted with MetaMask, MetaMask uses Infura. So yeah, I highly recommend getting involved. You don't have to be a developer to sort of poke around on their websites and make yourself useful. A lot of these people need documentation, people who can write well, people who just believe in the technology. And also, hackathons should not be intimidating. So at the hackathon we went to, there was definitely a lot of people who didn't necessarily know how to code, but were there for to learn at the workshops and stuff like that. And not to like advertise this a whole lot, but you can get scholarships to go because there's a lot of money in the blockchain space, and so it's a nice way to learn a lot more. So yeah, so this is just one final push to get you guys to go to things because there's a lot of opportunity out there, and it's there if you want it. So yeah, so homework, it'll be on Piazza. Yeah, so thank you guys, and have a great week. Thank you.